of you actually in the previous notes started asking questions about this, and it was kind of cool how you figured it out, and I want to kind of emphasize how knowing congruent triangles really helps this. Here's Theorem 4.5. It says the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So first of all, let me give you an idea what this means. It means that if I have this isosceles triangle and I draw the angle bisector of my vertex angle, I can automatically assume this is the perpendicular bisector. Now I'm going to put it in red. Why? Now remember, the two triangles are going to be congruent. I know triangle ABD is congruent because triangle CBD by side, angle, side. So right away I can use these congruent triangles to help me out. Because if I have a bisector of the vertex angle, I know two congruent angles and so on. So I have that down pretty quickly. Now remember, if two triangles are congruent, what do we know about their corresponding parts? Alright, CPC, TC means what? Corresponding parts of congruent triangles are congruent. I know that those two angles are congruent. If I have congruent linear pair angles, they both have to be 90 degrees. So that's where the right angle comes from. Then I also know that these two line segments are the same. So what I like about that, that shows it's a perpendicular bisector. So here's what we need to think. Surely kind of think of it like this. If, right now we go segment BD bisects the vertex angle ABC, okay, then segment BD is the perpendicular bisector of the base, which would be segment AC. So that's kind of the understanding behind this. I love this theorem because it fills in a lot of the information. Now we have two of the most common sense ones. We've actually talked about this before, but we didn't write it down formally. Now these are called corollaries. Now corollaries are same things as theorems, they're just really closely related. So it says if a triangle is equilateral, then it is equiangular. Basically, you can automatically assume it. And we talked about this the other day. So how could I do my shortcut? You say, hey, if you're equilateral triangle, then you're an equiangular triangle. You can automatically now go between the angles and sides. So if I have this, then I can go ahead and assume the angles are all congruent. Gotta love it. Basically, it's using the triangle, isosceles triangle idea. If they're isosceles, the base angles are congruent. If these two are congruent, then the base angles are congruent. Do you notice if I have congruent sides, automatically the angles across from them are congruent? It really helps out. Then we have our equiangular triangle. It's doing the same thing. If a triangle is equiangular, then it is what? Equilateral. It's using basically the converse of the isosceles triangle theorem. It says, hey, if I have all these three congruent angles, all three of the sides have to be the same. So equiangular first, then we have equilateral. Now, a few things you need to remember. To be equiangular, every one of those angles is how many degrees? 60 degrees. So don't forget that. That will just be helpful with calculations. All right, now we're just going to do some practice problems, friends.